Okay, I'm kind of continuing this topic because it will be also on ICT, and I'm actually just a couple of words about myself. I'm presenting here Moscow Lomonosov State University, and I'm originally a psychologist, but I have finished mathematical school, and this is my work with my colleagues on online platform where we try to implement the main ideas of educational research in mathematics in an ongoing online interactive platform, which is currently represented in quite a lot of schools you will see now in Moscow. And referring to these ideas of understanding in first, drill in practice as a second in the computer, actually we do all together in computer. We are trying to achieve conceptual understanding as by means of computer, and then to make drill and practice a bit more pleasant, doing it through the games with children. Let me show you. Okay, so what do we have in our system? This is basic curriculum, and now we have above 1 million of subscribed students, about 65,000 of teachers and so on. And what is noticeable that around 10% of them has finished all curriculum which we have given them. This is the first part of our program. The second part is advanced curriculum. It is a set of tasks on different topics. I'm sorry if I have mentioned that all of it is a primary school story. It's from first to the fourth grade. So, and this is about advanced curriculum. And the third direction is about concerns mathematics competitions, Olympiads. There are online Olympiads, and it's about 400,000 of children participate twice per year in our big Olympiads, and we also conduct small ones. How is it constructed? The structure, which actually I wanted to show you online, but I can't connect. I mean, I just connected to the internet now. It's not operating here, so it will be on by fingers. So what a student sees, it's a map of mathematics topics. It corresponds most partially, not fully, but we're trying to following the main topics which are represented in a standards, government standards of education, and the student is moved by a special creature who is our Dina. You could see him here. Where to go? He always tells the student where to go, and then he comes to particular tasks and solve them. So what are the main theoretical basis of it? It is, first of all, what I'm following, it's activity theory approach. So the idea is that it is task-based teaching. We don't give any videos, any explanation. We give just tasks one by one. But what is important that they're within the zone of proximal development. Am I going too fast? Does anybody follow it really? I mean, maybe, может быть, медленнее надо. Имеет смысл?
Do not switch the slides so fast.
Okay, okay. Yes. Okay. So, so it is the system of tasks covers all curriculum, and student starts from very simple tasks in order to be pleasant from the very beginning, because one of the problems at primary school that from already primary school they're terrified by mathematics, but so we give them very simple tasks, and then they quite quickly arrive to something that is more complicated to them, and it will be different place for each one according to his individual needs. And so then how education is happening, a child who already have a task and a goal receives some hints and explanations exactly at the moment when he has difficulties. And as all psychological research and educational research says, it is exactly what works, because the student is highly motivated at this moment to receive help. And so as a result, each student passes by his own trajectory the solution of the task. And one more important field for me, it is semiotics, coming from Press, McDowell, and Radford, currently Roth, by the way, half there. What does it mean? It is multiple representations all the time. We do try to represent each mathematical concept from all possible ways. So if it is addition, it is shown with cubes and with number lines, and of course with equations and word tasks, and so on. At the same time, what is important that we don't just show, okay, addition, it is 3 red cubes plus 4 blue cubes. We do let a child to interact with it. They appear to be like manipulatives for a child. And so a child has really a chance to make meaning from these representations. And many tasks are for transferring between of different representations. And also one more important thing, that in case of mistakes, we carefully guide attention of a child where he should look at this moment in order to understand. There are some examples of the task of how it looks. Let me see if it is connected to internet, then I could really do something. Okay, if it will connect soon, I will show you, but now I will just continue it with this way. So this is just an introduction of numeracy, and it is done in a few ways. Okay. Does anybody have this? Sorry, just 1 minute it will take, because I have connected before the presentation started, but somehow it was gone. I'm sorry I really apologize for this, but it's worse to see than just to talk about it. Quite strange to describe something interactive.
While one is trying to connect, and just take your time, don't worry. If any questions about what was said, it looks pretty natural and clear. Up to now, it looks like hundreds other systems of that kind. So perhaps at some moment we understand what's really new and important in this specific design.
Yes, okay. So what is really new and okay, that might be just a lot of efforts which were done in a particular each kind of the tasks, and also the way how it is presented to a child, because what is really unique is that a child has his own route through all of it. It's not just a supply of tasks which somebody needs to guide child through, but it is the whole system which guides the child through it. It goes from one to the next, to the next, to the next. So without any help, as I have told, about 90,000 of children has passed through the whole curriculum, and this is what is so unique, because for a teacher, especially this is a specificity of Russian teachers, it's difficult to choose what a child needs to do the next, and at this moment, this individual approach is lost, because the teacher provides tasks for the whole classroom, and the system provides tasks exactly for this child. So, and how it moves. So here we need to construct the model, and child has done a few like this for this, and I'm putting it here. For example, now I don't know what to do further because I don't understand, and then it will give me a hint. It will split 7 to 4, and then I know it's 5, and I'm going to put 5 here. Actually, that this is a visual representation of this additional task, and then I'm about to type it as equations, and now if I will type a mistake, it will give me a hint and connect to representation between each other in order to achieve some understanding, really, and so on. This is another one, and this is one of the possible tasks. Others, for example, this one is constructed in order to provoke embodied understanding of numbers. So in order for a child to understand how big and what are the relations between them, and he needs just to track to find a correct place for each block in a lorry, or in the truck. And what is nice about it that when he has done it, I'm ready to go. And it goes. You can imagine this is about motivation, yes, because children are really happy about it, and it's each time. And then it goes to be more mathematical. Here I will need to subtract. I can't just adjust by the size. And if the previous ones were a bit about conceptual understanding of numbers, the next one is just a drill and practice. And I agree, there is no way without it. But here we can do it in a funny way, yeah, because there is a sheep who tells us what to do, and there is this, I don't know how is it in English, to be honest, but it takes numbers, and then sheep also goes there, and then I need. Yeah, so then I need to do all of it, and as I will do it, as you probably can guess, the whole thing will live nicely, and also it appears like a game for children. Okay, I think that it's enough of an example, so let me continue a bit with the presentation. I think, I don't know, 5 minutes? 5? Yes? I can be very quick, actually. This we have seen, it's just more of examples, and it all works like this. And we have plenty of them, the whole program. And now it's a bit about advanced curriculum, how it is made. It is less interactive, actually. It has quite a diversity of different mathematical themes which can be given to primary school children. And it is placed by set of 3 tasks. Each time the main task is to solve the most complicated one, but there are 2 more which are working like hints. Let me give you an example. For example, I need to solve this, and I need to find out which number is hidden under each creature. And if I can't solve this, I go for this. If I can't solve this, then I go even for a simpler one. And by this, okay, all of us in Russian tradition knows that that a series of tasks are working pretty well, and we can come to very complicated ones, and teachers often write us how to solve it. They don't know, then they have, and it works not only for students but also provoking discussions in classrooms and at home. And okay, actually we made such a variety of tasks that about 30,000 of children have started to do these advanced tasks. Not many has finished all of them, just because they go up to the high level. And this is about mathematics competitions. That's what we are doing all around Russia. Once per year there are big competitions with 10 tasks in 1 hour. There are 4 more small competitions with less tasks, less time, and less participants. But what is important for me to point here that before each competition there is a training tour. There is a period of time when there are a set of tasks, like kind of preparation for the main competition, which are very complicated, and not necessarily very complicated, which might be quite complicated, and it provoke again discussions. So it's a way to popularize mathematics for students. And okay, you can find everywhere on Facebook and other chats discussing how to solve this task or that task between adults. And we put them in a way that it's not like the selective competition that only high achievement students would solve it, but it's pretty much for everybody. Somebody will have a low score, others will have a high score. And these are just samples of the tasks. They can be from all around things, like from a bit of graph theory when you need to, from Euler-Bridges task, you need to pass the country, each road 1 time, or here you just need to make a pattern, or this is a geometrical one. You need to cut by 1 cut this figure in order to make different combination of figures. And all of it, of course, is very interactive. And for example, like this, I need to make a projection here and there. No, that will not work. Yes. Okay, I think you got an idea of what should be done here. And this is how that one works. I choose the point. And you see the important part of it, that these competitions, they're spread widely around Russia, and they're pretty nice. Just pretty nice in design, which attracts attention of child very much. And we have, oh yeah, they are not so focused probably on the tasks themselves, but they're just happy that this boy, then I'm choosing one. This was resolvable, yeah. I'm choosing one, and then it flies here, and then it walks, and he moves his legs, as you can see. So all of it works like this. That's basically it. Yes, and we are Uchiru in Russia, and happy numbers. There are quite a lot of discretes in USA who also joined us. That's it, what we are doing here. I'm open for you.
Remarks?
Just probably one question. The competition that you mentioned, is it in Russia only, or is it
Yes,
national?
these competitions are in Russian. I mean, they're only in Russian language. Everybody can join. Sometimes they are usually provided during one day, for example, and people from USA tells, I can't log in because time has passed, then we do it for them. So people from all around the world can participate, but it's mostly in Russian. They're not translated so far in English.
Do the children use this program at school or at home? During class or during?
It is both. In some schools, not very many, there are lessons dedicated to Uchiru. In others, it is used after hours activity in the afternoon, or in most of the school, a teacher would give it as a home task. Please achieve this level or that level, and then children can use it at home. Yes.
Yes, please.
Do you know who is Bill Gates?
Personally, not yet.
Also Jobs.
It's the same way.
Be careful. Because it was forbidden for their children to go to the computer before they reached 14 years. After that, they had only 20 minutes a day to work with computers.
It's fine.
It was a
It's true.
comment. It was a comment.
It's true, and it's
But
fine.
you
And
understand something, I suppose.
no, I would rather like to respond, because it is a very good point. Each lesson, we have lessons. They're constructed in a way that, according to statistics, the medium child would spend about 15 minutes solving it. So we don't need more, and we advise teachers not to give more, because that's just enough. If you do it every day or twice per week, 20 minutes, you already have quite enough. Yes. Hmm? Yes, so for children, that's it.
Okay, what question? Yeah.
Maybe do you have some research on are the children that use the system are better after this than children that do not use the system?
We do have this research. We have, in some schools, we give them tests on paper, and we compare the class who was in it and was not. But it's quite hard to compare classes within it. What we can see that in classes between, because they also differ by teacher and all of it, but within one class, who has done more of this definitely has better results than who has done less. Yes, and in between classes too, but we don't have very widespread assessment yet, but we're working on it.
So, anyone comment? Thank you very much.
Yes, thank you.